can. A system of forces means a collection of forces. Some vertical forces or indirect forces or any force acting in different directions. Finally, we should determine the resultant. Resultant means it gives the same effect of all forces acting in the beam. But for every time, already told you, determination of resultant is not only determination of the magnitude and direction. We should determine kind of application where it is actually possible through that object and that location, whether from A, either from B, and then it is the full object we should know. Then only we can determine, possible to determine the equilibrium. Equilibrium means it provides equilibrium state to the body. Equilibrium state to the body will see next topic is our equilibrium state of the body. We will talk about that. Today it is the application. Through some applications we explain detailedly about the Varginoun theorem. Here first, number one, a system of loads or forces, both are same, acting on a beam AB is shown in the figure, clearly shown direction, attributes, point of locations, and see every load. Please check a solution. That we don't go for the solution. First you study what is given in the problem. For every force, individual force having 4 characteristics. That's why our resultant also should have 4 characteristics. Every force having which is acting on the beam, magnitude is the magnitude. Number 2, direction. Vertically it is 90 degrees. 90 degrees. Direction. Point of action. It is acting 1.5 meters from left side. That's the location where it is actually acting on the beam. Location or point of action. Number 4, pull or push. It is vertically downwards or downward. Pull or push. It is down vertically. It is pull. It is pull. Understand? For force or resultant, every force acting on the member having four characteristics. That's why we should determine 4 characteristics of the resultant. Then only it is mentioned. That's why first already you know how to get the magnitude of the resultant. R x is equal. Once R, it is Rx square plus Ry square. How to get this one? Already you know. Sigma x whole square plus sigma y whole square. What is sigma x? What's the meaning of the sigma x? X components of all forces acting on the body. Summation of all forces. X components of the all forces acting on the member. Every vertical force, every vertical force having only vertical component only. Why? Horizontal is cos 90 degrees is equal to 0. That's why only vertical component having here no, there is no horizontal component is 0. Here horizontal component is 0. You see, every inclined force having 2 components. acting like this. 20 mm, 20 kilonewton. How much this one? It is 30 degrees. This is how much? 20 cos 30 degrees. This is 20 sin 30 degrees. Okay, it is a trigonometry. Was it is 20. Once it is 20, it is 20 cos 30. It is 20 sin 30. Okay, already know. It's 20. Once it is 20, its length is 20. What is this length? What is this length? Once it is alpha, this length is 20 cos alpha. That's all. Like this. It is a 20 sin 30 degrees acting right to left. We should mention the direction also. We should mention the direction, and that's what sin 30 is nothing but half. That's what it is. 10 kilonewton. That 10 kilonewton gets sigma x is 10 kilonewton. It is acting right to left. Next we come to the sigma y. All is the sum of all vertical components and considering top to bottom positive. Top to bottom down positive. Positive. Here only 20 plus 30 plus this one 20 cos 30. 20 cos 30. How much this one? Finally, we are going to get time wasted. 1, 3, 2. That's why it's acting like this. 67.32 kilonewton. Its resultant is like this. This is the resultant. Resultant is already know resultant from here. 10 square plus 67.32 square. This value is 68. 68.06. This is equal to 68.06. It is the inclination alpha. We know the magnitude over. Determine the magnitude 68.06. It is direction is going to get alpha is equal to tan inverse inclination to the horizontal. Inclination of the resultant to the horizontal is equal to tan inverse 67.32 by 10. That is equal to alpha is equal to 81.55 degrees. 81.55 degrees. This is alpha. It is 81.55 degrees. This is 81.55 degrees. This kilonewton. Next, find us action. It is already known. It is acting in direction. It's also over. It's also over. Pull. It is pulling like this. Pull like this. Two chances are there. Like this or like this. One finally, find the action of the force over the beam. For this purpose, general purpose, it's easy for us, but this one, Varginoun theorem is very visible here. Okay, Varginoun theorem. What is the definition of the Varginoun theorem? Varginoun theorem. Sum of the moments of all the forces acting on the beam is equal to the all the forces acting on the beam with respect to I am take A as the moment center. Moments. All the moments of all the forces acting on some of the moments of all the forces acting on the beam is equal to moment of with respect to this moment center is equal to the moments of the resultant with respect to the same moment center E, you see, it is how much? Clockwise I am taking positive. Clockwise positive. Anti-clockwise I am taking negative. Listen. Only moment of force, only two directions. Clockwise direction or anti-clockwise direction. You take clockwise direction as positive or negative. But in this case, in our problem, I am considering clockwise direction, clockwise rotation, clockwise moment as a positive. I am taking anti-clockwise rotation or anti-clockwise moment considering as the negative. Sigma MA I am taking with respect to A. That means sigma MA is nothing but some of the moments of all the forces acting in a member with respect to this point. I am taking this one. Moment. It is acting clockwise. That is 20 into 1.5 Newton plus or minus. It is also acting clockwise direction. 30 into 3 plus this one. It is also reacting clockwise direction only. Plus it's here. This is the position. Actually, it is 6. It is the cos 30 degrees. Force is how much here? 20 cos 30 is the force. 20 cos 30 degrees is the force into moment arm. Moment arm is 3 plus 3, 6. 6 is the moment arm here. Force into moment arm. That is nothing but moment of force. It is also acting this one. And one more. One is acting like this. That means there is no distance between the force and the moment center. That's why nothing, no effect. Your x component giving no effect in moment. It is not giving any moment. There is no giving any effect. Rotational effect. It is not giving any rotational effect by x component of this 20 degrees force acting at 60 degrees to the beam. Okay, that's all. Right side. RD is nothing but what is the RD? Okay, here also we can take this one. This force acting like this. It is the RX. It is RX is nothing but, tell me, this is how much? Finally, we get x value is equal to in our textbook given in a tough manner. It's a very easiest manner. X value equal to 3.326 meters. It's a very important one. It's 3.326 meters. Finally, solution answer is given. We mention all. It is point of application is 3.326 meters from left end. 3.326 meters. Our resultant force acting at 3.326 meters from MA. You should mention that one clearly. Don't put 3.326. You should mention 3.326 meters with all four. Then only it becomes full-fledged answer. Full-fledged answer. Sir, it is one more application for the Varginoun theorem, moment of force, and system of coplanar system of forces. Coplanar system of forces. Here totally is a diagram. This is one of the machine member. Four forces acting at member. 1, 2, 3, 4. One is the horizontal force. Another is the vertical force. One is inclined pull. Okay, it is 30 degrees. It is also another pull that 60 degrees to the horizontal. Okay, all forces, you know, it is a really force having four characters. First, you should know that. Till now, our thinking only two. That's the direction and the magnet. But every force having four characteristics. Number one is how much this one? 100 newtons. 100 newtons. This force I am considering one force first. Having 100 newtons magnitude and 60 degrees. Direction is 60 degrees to the horizontal, and third one is pull. And point of application is acting at that point of one end. Okay, that's the A. All same. That's why our resultant we should determine as per our given data. What's given? Find the resultant. We should determine the resultant. Resultant means we should determine four characteristics of the resultant. Number one, magnitude. First of all, what is the magnitude? What is equal to? Already sigma x whole square plus sigma y whole square. Sigma x is, what is the sigma x? Sigma x is all x components of the all forces given in the figure, and some of the all y components are vertical forces, all vertical components of all forces. Some of the all vertical components are y components of the all given forces. Okay, sigma x is equal to that mean? Sigma x is equal to, what's this? Already you know, every inclined force having two components. One is the horizontal component and one is the vertical component. Here it is working like this. It is horizontal component. It is right to left. I am taking right to left is positive. Right to left is positive. Consider here. Sigma x is 100 cos 60 degrees. 100 cos 60 degrees. Another thing is, it is a vertical. There is no I am taking top to bottom positive. Top to bottom positive. Here it is 100 sin 60 degrees. 100 sin 60 degrees. Please all of you remember, once it is acting like this, forces are also acting same direction. The components also understand. Why? Because loop is required. Loop. Understand? Please remember this point. Once acting like this, one is like this, one is like this. Next, I should take upward is negative. I am taking this one as negative. And thumb is positive, plus 80. Vertical component. Next here, 120 plus positive is 120. 120 sin 30 degrees. Sin 30 degrees. That is equal to 53.4 newtons acting downward. That's why all of you see here sigma x acting right to left. That is equal to 73.92 Newton, and one more is like this. We should create the looping. It is 53.4 resultant like this. R is equal to how much? From here 73.92 plus 53.4 square. That is equal to R is equal to 91.19 Newton. Here, first one we finished. Magnitude 91.19 Newton. Next, direction. With respect to horizontal, you should mention that one also. With respect to horizontal, I take this one as alpha. Alpha is equal to tan inverse opposite side 3.4 by 73.92. That is equal to 35.84. 35.84. Already given here. It is a resultant R is equal to 91.19 Newton. Direction is 35.84. 35.84 degrees. 35.84 degrees. It is acting inclinedly downwards. That's why number 3, incline downward. Incline down. That's 3 over. Number 4, point of application of the force. Point of application. Varginoun theorem. What's all of you know about this one? Then all of you know. You should apply Varginoun theorem. According to the Varginoun theorem, moments of all system of forces, coplanar system of forces. Coplanar or Varginoun theorem is applicable only for coplanar forces only, not applicable for the spatial forces. Okay. Moments of all coplanar forces system acting over the member with respect to the moment center in their own plane. Moment center I am taking A. Sigma MA moments of all forces acting on the member with respect to point A. It is also the value on the same plane equal to moments of resultant with respect to the same moment center, that is R is a resultant into it is a resultant means it is a D. Perpendicular distance we should determine. It is a D. It is a D. Perpendicular distance. Moment center is nothing but perpendicular distance. Perpendicular distance of the force from the moment center is the D. But we should determine its value. That's why RT is nothing but RX is acting like this, as RY acting like this. RX distance, perpendicular distance of RX from A is 0. That's why it is 0. Plus RY into X. RY into X. RY into X. That's why MA values. All of you, please understand. Try to understand. MA sigma MA is equal to this force. No effect. Why? Because x-axis no distance. Y component no distance. I am considering here clockwise as positive. I am taking clockwise. Take positive or negative, it doesn't matter. But considering, we mentioned that one also in our answer. Clockwise as positive. That's why. Once it is the point, once you push this, it will rotate. It tries to rotate the lamina clockwise only. That's why. This is the distance. This is the, how much this one? Given the length given here. 100 mm. This is 100. This side. This is the 50. 80 into 50. 80 into 50. Moment center is, moment arm is 50. Moment arm is 50. Force is 80. That's next. This one, this force, horizontal force, it is also the clockwise. It gives clockwise motion or rotation or effect to the member. That is this is the distance. How much this one? Tell me. 100. This is 100 cos 100 sin 60. 100 sin 60 or 100 cos 30 degrees. Okay, once you consider this as 30, 100 sin 60 plus 100 sin 60. The distance, this is 100 sin 60, is the distance, perpendicular distance of this force from the moment center, and force is 80. Understand all of you? 80, force is 80, perpendicular distance is 100 sin 60 is the perpendicular distance. Force acting, it is the perpendicular distance of this force from the moment center. Next, another force, vertical. It is how much? 120 sin 30. Force is 120 plus. It is also plus. All are rotating, right to rotating this one in a clockwise direction only. That's why it is 120 sin 30. 120. This is 120 vertical. Horizontal is possible this one. Okay, it is giving only vertical component only, giving 63.4 into x. Finally, after calculation, x value is equal to 317.008 mm. This is the 100 mm or 100 mm. Okay, here the point of application of resultant force or is equal to application, the point of application resultant from end A is equal to x is equal to how much? 317.008 mm. You got all four or not? All four or not? It is resultant force, that is acting pull. It is also giving this one also giving all forces giving clockwise. Our resultant also gives clockwise motion, clockwise rotation, clockwise effect to the member only. That's why member rotates clockwise. Finally, we decide the rotation of the member also we can decide. Member rotating clockwise with or resultant how much? Magnitude 91.19. It is rotating clockwise direction with force of 91.19. Understand? The force acting at 317 mm from end A. Understand all of you? With the force